Welcome to The Explainer. Today, we're going to unpack chaos theory, this incredible idea that finds hidden patterns and things that seem totally random. But we're not going to start with some crazy equation. Nope. We're starting with a story, a little what if that could have changed absolutely everything you know. So picture this. The year is 1905, we're in Bern, Switzerland, and a big clock tower in the middle of the city. Well, it's running just 2 minutes late. Seems like nothing, right? I mean, who cares? It's just a tiny little mistake.
But here's the thing. Because that clock is off, a man who relies on it to get up for work ends up leaving home 5 minutes later than he normally would. His whole morning schedule is just slightly shifted.
Now, because he's in a different place at a different time, he steps into the street just as a car with bad brakes comes around the corner. He's struck, and tragically, he's killed. And that man, get this, was a young Albert Einstein.
So what's the big deal? Well, without Einstein, those 4 revolutionary papers he wrote in 1905, the very bedrock of modern physics, they never see the light of day. And the dominoes just start to fall. Think about it. No GPS, no laptops, the very screen you're looking at right now, poof, gone. Our entire modern world just erased.
So could a tiny 2-minute delay really wipe out our reality? This whole thought experiment is the perfect way to understand the heart of chaos theory. You've probably heard of it. It's called the butterfly effect, the idea that one teeny tiny change can cascade into massive, totally unpredictable consequences down the line. To really get why this idea was such a bombshell, we need to hop in a time machine and see how scientists used to think about the universe. And let me tell you, it was a completely different picture. For hundreds of years, thanks to geniuses like Isaac Newton, most scientists saw the universe as this giant, perfect, predictable machine, like a massive clock. They called this idea total determinism. One physicist, Laplace, even said, hey, if you could know the exact position and speed of every single atom in the universe, you could calculate the future perfectly. Everything would be known. And you know what? Simple things seem to prove him right. I mean, look at a pendulum. If you know where it starts and how hard you push it, you can predict its swing perfectly, forever. If you were to draw its motion, it would just be a simple, repeating loop. It's clean, it's tidy, it's predictable. So you've got this clash of 2 huge ideas. On one side, the old school view, the universe is a predictable clock where simple causes have simple effects. But then chaos theory comes along and says not so fast. It says tiny little changes can lead to wild results, and predicting the long-term future, forget about it. It's impossible. So where did this wild new idea come from? You might think it was some big planned out experiment, but no. It was discovered completely by accident, all thanks to a meteorologist, a very early computer, and a coffee break. All right, so it's 1961, and this meteorologist, Edward Lorenz, is using a computer to simulate the weather. One day, he wants to rerun a part of his simulation, and to save some time, he just types in the numbers from an earlier printout instead of starting all over. Then, he walks off to grab a cup of coffee. When he gets back, his jaw hit the floor. Here was the problem. His computer was super precise, using numbers with 6 decimal places, like 0.506127. But his printout, to save space, only showed 3 decimal places. So, he just typed in 0.506. He rounded it. That difference, that 0.000127, was microscopic. I mean, we're talking about a difference as small as a single speck of dust on the Eiffel Tower. And yet, that tiny, tiny change was enough to make his weather simulation go completely haywire. At first, it looks the same, but over time, it diverged into a totally different long-term forecast. This shocking discovery led Lorenz to come up with that famous metaphor to explain this bizarre phenomenon. He said that in a complex system like the weather, even the smallest disturbance, something as tiny as the flap of a butterfly's wings in Brazil, could in theory get amplified and amplified until it eventually kicks off a tornado in Texas. This leads us to a really cool and kind of weird paradox. How can a system follow the laws of physics perfectly, meaning it's what we call deterministic, but at the same time be totally and completely unpredictable over the long run? This right here is the absolute heart of chaos theory. It's called sensitive dependence on initial conditions. All it really means is that for some systems, any tiny little uncertainty you have at the start, and you always have some, will get magnified over and over until your prediction is basically useless. The error just grows and grows. A double pendulum is the perfect example of this.
It's just two pendulums stuck together. It follows the same simple laws of gravity, but because of this sensitivity, you can never ever release it from the exact same starting point twice. And so, every single time you let it go, it performs a completely different, chaotic, and beautiful dance. It's impossible to predict.
But wait, here's where it gets really beautiful. Chaos isn't just a messy, random free-for-all. Hidden inside all of that unpredictability, there's actually a surprising, elegant, hidden order. So even though you can't predict exactly where Lorenz's weather simulation will be in a month, its behavior isn't just random noise. If you were to map out all the possible states the system could be in, the points wouldn't just be scattered everywhere. Instead, they get pulled toward a very specific, hidden pattern. Remember our simple pendulum? Its path was just a boring, predictable loop. But for Lorenz's chaotic weather model, the path it traces creates this incredibly complex and beautiful pattern that looks, well, it looks just like a butterfly's wings. It's called the Lorenz attractor. This system is always drawn to this shape, even if we can never know exactly where on the wings it'll be.
Okay, so this is all really cool math, but why should you care? What does this have to do with any of us? Well, it turns out these chaotic systems are literally all around us, and understanding them changes everything about how we see the world.
Because we get chaos theory, meteorologists don't just run one weather forecast anymore. They run dozens, each with a slightly different starting point, to give us a range of possibilities. It explains why stock markets are so volatile and why we have to think in probabilities, not certainties. It even helps doctors understand chaotic systems in our own bodies, like an irregular heartbeat. And hey, ever seen one negative comment on social media explode into a massive online fight? That's chaos too. At the end of the day, chaos theory shows us that there are fundamental limits to what we can ever hope to predict. But it also shows us that there's a beautiful, hidden order in things that just look random. It helps us see the universe not as some simple, boring clock, but as something way more complex, more interconnected, and honestly, a lot more interesting. It teaches us to stop trying to predict the future perfectly and instead start planning for a whole range of futures.